Today we're going to be going over our torque arm. What you'll need for this are the torque arm apparatus, a 10 Newton scale and only a 10 Newton scale, some string, a mass hanger, and a protractor.
Supplied also somewhere on the cart should be an amputated arm. You're going to weigh this arm. The center of mass is located for you, and the distances from the center of mass to where the joint is, where it's going to pivot about, those distances have already been drawn on there, so you can measure those distances. Notice the distance from the joint, from the pivot point to where the rubber band, which is serving as the biceps, so the biceps are connected from bone spur A to bone spur B, C, D, A to C. And so the distance, the position vector from pivot to where the force of the bicep is in that direction, the force of the bicep at B, that length, that leverage, the lever arm, the position vector from pivot to B is what you'd measure. And with that information and the angles between the force of angles between the lever arm from pivot to B, that angle to the angle of the force you would record. And the force of the weight, of course, is vertical, but the force of the weight vertically down, you measure the angle from the lever arm from pivot to where that force is being applied. That's the point of the torque. And so you measure the angle then between that guy's lever arm to the vertical force down. So that's going to be greater than 90, and this will be less than 90. And then you'll move the bicep to be closer at B or farther away at the bone spur D. And to test out to see if your calculations are correct, you'll remove the rubber bands and attach a string. With the rubber band removed, the string will serve as the bicep. It'll be looped onto B, and then the other end of the string will be this and only this 10 Newton sensitive scale to see is your calculated expected force of the bicep the same as what the string is going to be pulling on. And don't forget to wear your safety goggles.